It's been really fascinating to hear about the amazing technologies in healthcare. I think some of it just a few years ago would have sounded like sci-fi, like ambient physiological monitoring. That's something that's really phenomenal to hear about. But what's really interesting is to really see and hear about all the examples of real transformation. There's a lot of big disruptors that we heard about that have quite a bit of muscles and can come in and leverage their technology to change things around. And a lot of lessons learned also from that to draw from. When we try to think about digital transformation for the built environment, there's a similar need also transform our industry using technology. There's a lot of cool technology out there. I think some of the challenges being a technology enthusiast is a lot of it is sold like silver bullets, BIM. There was a lot of hope on BIM, a lot of hope on 3D laser scanning. Now we hear a lot about AI and machine learning, and it's true, the potential is great, but I think it requires quite a bit of hard work for us to do. So, I think, pretty much like everybody is in love with the potential of what technology can do, but at the end of the day, I think there's some realities that we have to recognize to really fully realize the potential of technology. The way I look at it is that there's really no other way. Like, you have to embrace digital transformation because it's going to help us solve a lot of problems moving forward. We heard yesterday about the increased age of experienced professionals and the limited pool of professionals. I mean, I know that from the healthcare market in LA where I live, I see a lot of my colleagues on the design engineering side hopping from one organization to the other. It's a closely tight-knit circle. But similarly, with the recession, there was a lot of just outside of design and construction and project management, on the construction side, there's a lot of skilled workers that left the industry and never really came back. I think, we heard about the challenges of attracting new talent, and I think the gimmicks and the gadget aspect of some of the technology is really starting to kind of attract a lot of the young population, similar to what the gaming industry has done. But really, to close the gap between the reality of where we are in digital transformation and realizing the full potential of the technologies in design, construction, and project management, I think, got a balance between the development of the resources, the processes, and the tools, and ideally, all of the organizational knowledge and the collective knowledge becomes embedded in the tools. I actually truly believe that there couldn't be just an excuse that we don't have experienced people. We have to kind of all think creatively about how do we basically turn the collective knowledge and experience into lessons learned embedded within our systems and tools that we use.
Thank you, Mo. My name is Matthias Ebinger, and when I open my mouth, people always come up to me and say, "You must be from New York." And I always say, "Yes, that's true." I was born in Germany, have a little bit of an accent, but I am from New York. I've worked in New York City with New York Presbyterian for many years, and I was always a little bit frustrated. We have a lot of smart people in facilities, design and construction, engineering, and I was always wondering, why is it so hard for us to get our data in order and to have data do the cool things that we see Google do with data and that we see Apple do with data. We heard a lot about the realities in facilities engineering, design and construction. The challenge being we always do unique things that are not replicable. So we don't have the economies of scale that a Google has or an Apple has. We don't deploy software that then gets replicated 100,000 times. We have one building, and that building setting, translating into a data set is very complex. If you look at your machine room, how do you take that complex structure and how do you translate this into a data set that allows you to take the complexity and really turn this into a set that can talk to you about risk, right? If we think about compliance, we all agree compliance should be best practice hard-coded into regulation. Unfortunately, compliance in most of our experiences is us chasing the next survey that we have to comply with, making sure that our books are in order, our paper books in many instances are in order, while the organization at the same time expects us to support growth. Our aging facilities, we have heard about it. Our aging facilities make it really hard to support that growth that we are expected to deliver. And then at the same time, with all of that in place, we should look internally at our teams, and we should be able to deliver productivity to make sure that our teams are as efficient as they could be, while we have this messed up data set that is very, very hard to get any sense out of. So what do? Digital transformation, as Mo had mentioned, has come along over the last few years with a few promising strategies. The first one was BIM to FM. I was in many presentations being on the owner side, where the contractor came in, the BIM team, and said, you're going to get this fantastic model. It's going to not only do your preventive maintenance, it's going to do all your service calls, and it's going to do condition assessment for you long term. Contractors didn't realize that we don't have a whole trailer full of young people who do nothing else but BIM work, right? We have one person, two people, if you're lucky with our health system, who have to maintain that data set once it's being handed over to us. So there was a misalignment with what BIM does in construction. BIM in construction has proven over and over again for the last 15 years to be essential. In maintenance and operations, BIM has just been too much, too heavy, too expensive to maintain. The cost of data sustainability has been very hard. We have very tight budgets on the operating side. We have to have data sets that are lean, that support very precisely what our use cases are, and that are efficient in supporting us, how we run our facilities. The other strategy is what we have done all along. It's incrementalism, right? So we inherited a data set from our predecessors. Somebody, maybe in the late 90s, did an asset inventory. They put barcodes on equipment. I've worked with New York Presbyterian on equipment that had 6 different generations of barcodes, right? So lots of good ideas, lots of people. Here's an example of a VAV box. Contractor did the right thing in their spec. It says you have to put a tag on. The contractor did it nice, right? National CAD standard tag. Then we put a barcode on. A few years later, somebody else went up there and put another barcode on. Good ideas, lots of good intention, but everything kind of disconnected without really moving in the same direction. Often it just felt like this, right? This is not rocket science, but it's quantum physics. Lots and lots of moving parts, and they are all over the place. It's very hard for us as facilities engineers to pull everything together. And yet we all agree what should happen is this, right? So easy to do, easy to say, very hard to do. What we have found over the last years with facilities really tackling that problem, facility leaders take ownership of their data and realize that it's not the consultants that should manage data. It's not the architects that should come in and establish the inventory and then us relying at the end of a project of getting a good set. We as facilities engineers, we have to own our data and we have to own the right set of data. We have to know what we have to understand our portfolio, and we need to drive the data through the entire life cycle. From the planning phase, we need to tell designers, contractors what they start with. We don't necessarily want to interfere with how they run their construction project. They know for sure that much better than we do. But at the end, we want to have a certain relatively small set of reliable data that we can then ingest and merge back into our master data set. The other thing that has changed over the last few years is how we interface with software. We have always felt that we run our business a certain way and software needs to adjust to us. That is changing. People are realizing that software, as matured as it is today, is hard-coding best practice. So a lot of smart organizations look at software packages, take time to learn how the software thinks, how the software works, and then adjust to that software. So if you do capital construction, if you do maintenance and operations and you have a software package, that package was designed with a certain intent. It's very important to understand the intent, and if you can align with that intent, you get much more value out of that software. And then the final piece, good data doesn't come for free. If you do incrementalism, if you hope that BIM is going to save you, it won't happen. Good data requires an investment. It requires an ongoing investment on the operating side. You have to have a strong in-house team that understands data, that can manage data, and you need to have an initial investment to lift you so that your existing data set can actually migrate into an environment that you can then sustain over a long time period. The good news in all of this is the cost for setting up a good data set has significantly dropped, and very recently dropped dramatically, to a point where laser scanning of your facilities is now actually a reality. We've always seen it, we've always known it's cool, we've always seen it works, but now it's also affordable. So just recently we saw the price for scanning of a facility outside and inside to drop down to less than 10 cents per square foot. That was unheard of before, and that includes the development of a Revit model. So what you see here is a campus situation scanned that then supports very efficient development of what we call lean BIM or owner's BIM, a BIM model that is very streamlined to support space management, life safety management, and asset management in a very, I don't want to say simple form, in a very efficient way. And so once you take the scan away, you have a full 3D model that's reliable, that is designed in a way that you can actually maintain with your in-house resources this model on a long-term basis as your facility gets changed. And that is really a game changer, because in the past that has just not been possible. We started out with data that we inherited. If we were lucky, we had a CAD operator that maintained the drawings. More often than not, we just had layers and layers of drawings that sat on top of our original CD package. You know, if we were lucky, we had a conformed set at the end of a project, and then we had many, many years of projects happening. With this, you can actually re-baseline, start out, set up a clean starting point, and 3D modeling, Revit, for operations is actually, and we've done a test again and again, we've tested it with in-house resources, with partners. If you set up your master model in Revit, it is much easier and much cheaper to maintain than if you maintain it in 2D CAD drawings, the way most of us currently do it. The real big transformation that has happened over the last few years is really this. We have, for the first time, equipment that our guys actually like to use. So in the past, we've rolled out those Motorola bricks. You know, many of them ended up in buckets of waters. They were clunky, and most importantly, they were just not easy to use. And rolling out iPads, when we did this early on, 5-6 years ago, the teams would typically say, this is the equipment that gets, you know, when we leave the hospital and we go into the rough neighborhoods, these are the pieces of equipment you get marked for. It turned out that in rolling out hundreds of iPads in many, many different places, we have seen one iPad getting really truly lost, you know, under suspicious circumstances, and a handful of them getting damaged. Everything else is well taken care of. Mechanics, they treat their iPads the way they treat their equipment. They take care of them, and they are proud because they have a piece of technology that they feel good about, that they can proudly walk around with, and that allows them to actually access information in a way that they previously have not been able to. So how do you structure a digital transformation? The most important part is to have a very clear strategy. So you can, if you are lucky, you have capital to invest and to move quickly. If you don't have those resources available, you have to do it in smaller steps. But as you move through those small steps, or as you take those big steps, the most important part is to have a clear strategy. It is important what you want to get out of your system, what kind of analytics do you want to drive from it, what kind of processes should be supported by it. And so here's an example of a healthcare system that did this very systematic approach. They said, we want to have our real estate portfolio. They had 350 service locations. We want to have the real estate portfolio tracked. We want to know, what our single, double, triple net leases are. We want to understand what we are responsible for. What does our in-house team do? What does our real estate team do? And what does our outside vendor do? And if there's an issue, if somebody submits a ticket, we want to be able to wear those work orders out. Then, for those locations that are licensed, we are doing a 3D laser scan. So we are, from the 3D laser scan, developing Revit models. Those Revit models, in fact, have a database built in, so you can do space management directly in Revit. Autodesk Revit turns out to be a database software as much as it is a 3D modeling software. Revit allows you to generate your 2D drawings, both for space management, architectural services, as well as for life safety. You can also, within Revit, store your engineering drawings, so you have everything in one place. You put it on the cloud, you have your outside teams access it. It becomes a very concise environment. You then overlay your assets on top of it, and ideally you do it in a way that your mechanics in the field that are actually responsible for maintaining the equipment, that if they find a mistake, if an asset is not placed in the right location, you want to give them the ability to move the asset from one place to the other to make the change right here and there so that they, if they see something being wrong, have the ability to modify the data right there. Setting up an ITM program that is compliant with Joint Commission requirements, with CMS, with NFPA, with FGI as far as it pertains here, then allows you to set up a data history that once you connect that to an analytics tool, gives you the ammunition that you need to do your AEMs to really justify that certain equipment needs to be inspected more or less frequently compared to what your baseline is. Now, the most important part in all of this in healthcare is that we are already a very structured industry. Regulation makes it very clear what we have to do. So between NFPA, between the FGI guidelines, and other industry standards that are available, we know what we have to do. The only thing is that our data is not yet aligned with it. So what we are typically doing with organizations is go back, start out with the standards. What standards are you following? Then translating this into maintenance requirements, giving it to the team so that they can actually deploy it in the field, and then the engine starts. That then, once you have a meaningful data set, allows you to do analytics, so you have your advanced reporting, and starting very slowly at this point with the data being reliable, you see AI and machine learning emerging. So you have a few examples here. An interesting one is hot cold call analysis. So we can predict with over 90% certainty when you are going to get a hot cold call, and that's directly related with weather. In the New York region, it's related to humidity. It's amazing how accurate those data sets are. And then you can see if you suddenly get a spike in hot cold calls that is unexpected, that's where you want your engineers to proactively reach out and see what's going on. And we have other areas in optimization where you look at total cost of ownership, productivity, and other areas. One thing that is very important to us as we work with many organizations across the country, we see that everybody is solving the same problem. Everybody either solves it in-house or works with consultants, but a lot of it is common. Standardization of how you call your assets, how you classify your assets, how you name your spaces. All of this is actually common across the industry, but we all have to invent it again and again. We spend a lot of time when we do a typical consulting engagement, the first month, 2 months is negotiating what do you call your equipment. You know, what is an asset? Is an air handler an asset, or are the components within the air handler an asset? How about if we as an industry said, let's agree on one standard, very basic standards on what we should, as an industry, call our facility assets. So over the last year, we have partnered up with a good amount of healthcare systems, some of which are here, and we have said, if we run facilities and if we follow standards that we all are following, there is really no reason why we should not call systems and assets the same, and spaces, and even what we call zones, patient acuity zones, the same. Imagine if you could do a risk assessment on 27 systems in a building against 20 high-risk patient zones, how easy that would be, as opposed to if you had to risk assess 4,000 assets, 600 of which are exit signs, and you would then have to see where they are, and you have an inventory of, let's say, 6,000 rooms in that building. So a standardized approach driven by codes is something that we as an industry really should be striving for. So we've gotten a few organizations line up. FGI is very interested. We spent some time going through the FGI guidelines. We pulled out from the different chapters of what the design requirements are, and then very simply just came up with a naming convention. And if you pivot a naming convention, you now have a very, very simple spreadsheet that tells you how to call rooms. And if you are not really sure, and if your junior person who is working in your team is not really sure what that room is all about, there's a reference that ties back to the FGI guideline that then tells you, the whole context of what the definition of that room is. And the other piece that falls into this very nicely is that you have an alignment with the ASHRAE 170. And so you have the ventilations, the room nomenclature, and compliance with FGI right here in a very simple spreadsheet. And then the second part with this is on the maintenance side. So if you list all of your Joint Commission requirements, for those of you who are Joint Commission certified, you know them very well. And then you have all your code requirements from CMS, NFPA, and some other agencies. If you take the details here, you can set up a very structured maintenance program. So here you have NFPA 25 sprinklers. you can set up a very, very structured maintenance program and tie that back straight to your asset classification schema. So a lot of groundwork has been done in those standards. We are using industry standards, and over the last few months, we've started to reach out with, to FGI, ASHI, ASHWE, and then the Construction Specification Institute. We are forming a coalition of partners. And what we are doing over the next year is to work with these teams to publish best practice guides. So when you start revalidating your assets or doing it for the first time, if you take that new community hospital and you merge it into your health system, that you don't have to start from scratch, but that you have, in terms of asset naming conventions and in terms of space naming conventions, that you have a standard to start with. We have about 15 health systems that are part of the initiative. We are currently folding this into the committee structure of both the FGI and ASHWE, and we're looking for partners. So if you are in the process of standardizing your asset nomenclature, your spaces, reach out to us. We are facilitating it, Mo, myself, and a few other people. We'd love to bring you in touch with the group, and we would love to have the momentum that you have within your organization to contribute to this overall initiative to say that, at least from a naming convention, we in healthcare should not have to reinvent the wheel again and again. Digital transformation is about standardization. We as an industry do a lot of things the same across the board. Let's get organized and let's do this in a way that we can actually share our common experiences and be efficient with how we organize our data. Thank you very much.
Thank you very much, Matthias.